A machine element is subjected to the following biaxial state of stress. Sigma x is 20, sigma y is equal to 20 megapascal. Both are given as tension, and tau xy is equal to 40. The shear strength SSY is equal to 100 megapascal. The factor of safety as per Tresca maximum shear stress theory you have to find out. According to the Tresca theory, we have tau max, which one is the absolute value, is given as sigma 1 minus sigma 3 divided by 2 is equal to SYS divided by factor of safety. First you have to find out which one is the largest principal stress and the minimum principal stress. For this one he has given the biaxial state of a stress. So in the biaxial state of a stress we have given the value of sigma x, that is the normal stress acting along the x direction, equal to 20 megapascal. Along the y direction we'll take is tensile positive, equal to 20 megapascal, and the shear stress is taken as positive. So if the tau xy on the x phase will rotate clockwise is taken as positive value. So this direction of arrow was wrong, so it will be leftward. So this value of tau xy is equal to 40 megapascal. So we have sigma average will be equal to sigma x plus sigma y divided by 2. In this case we have sigma x is equal to 20, sigma y is also equal to 20 divided by 2. So sigma average is same as equal to 20, and we have tau max is nothing but the radius of Mohr circle is given as under root of sigma x minus sigma y divided by 2 whole square plus tau xy square of it. So tau max will be equal to under root of sigma x is equal to 20, sigma y is also 20, so we have 20 minus 20 divided by 2, and again we have square plus we have 40 square. So tau max will be same as equal to 40 megapascal. In this case we will get the value of sigma a will be equal to sigma average plus tau max, that is equal to 20 plus 40 is equal to 60 megapascal. And the second principal stress is sigma b will be sigma average minus tau max. One value you have to take positive, other is taken as negative, is 20 minus 40 is equal to minus 20. Out of 60 and minus 20, we'll assign the value as sigma 1 is the highest value, equal to 60 megapascal. Sigma 2 will make it equal to 0, and sigma 3 is the least value, is equal to minus 20. Always you have to arrange sigma 1 greater than equal to sigma 2 greater than equal to sigma 3. So we know the value of sigma 1, sigma 3 and SYS, which is equal to 100. We have sigma 1 is equal to 60 minus sigma 3 will be equal to minus of 20 divided by 2, and we have SYS is equal to 100. Using this we can calculate the factor of safety n. So we have factor of safety is 200 divided by 60 minus 20 is 80. 200 divided by 80. So we get a factor of safety according to the maximum shear stress theory is close to 2.5. The principal stresses at a point inside a solid object are sigma 1 equal to 100, sigma 2 equal to 100, and sigma 3 is equal to 0. So we have sigma 1, sigma 2, sigma 3 value are given. That is, all the three principal stress are given. The yield strength SYT is equal to 200. The factor of safety calculated using the Tresca maximum shear stress theory we have to find out. So for maximum shear stress theory, we have tau max is given as sigma 1 minus sigma 3 by 2 is same as equal to SYS divided by factor of safety, or is same as equal to SYT divided by 2 times of factor of safety. Three principal stresses are given directly this time. We have sigma 1 is equal to 100. Even the value of sigma 2 he says equal to 100. So we have to assign the value of sigma 2 is equal to 100 and the sigma 3 is equal to 0. So already this is arranged. We have sigma 1 is greater than equal to sigma 2 is greater than equal to sigma 3. So all values are known. We can directly apply the given equation. We have sigma 1 is equal to 100, sigma 3 is equal to 0 divided by 2, and we have SYT value is given as 200 divided by 2 times of factor of safety n. So 2 and 2 will get cancelled, and we have factor of safety is equal to 200 divided by 100, that is equal to 2. The principal stresses at a point and a critical section of a machine component are sigma 1 equal to 60 megapascal, sigma 2 equal to 5 megapascal, sigma 3 equal to minus 40 megapascal. So they are arranged. Sigma 1 is greater than equal to sigma 2 greater than sigma 3. For the material of the component, the tensile yield strength SYT is equal to 200 megapascal. According to the maximum shear stress theory, factor of safety we have to calculate. So factor of safety according to the maximum shear stress theory is tau max absolute is sigma 1 minus sigma 3 by 2 is equal to SYS divided by factor of safety, or is same as equal to SYT divided by 2 times of factor of safety. And we have given the value of sigma 1 is equal to 60 megapascal, sigma 2 is equal to 5 megapascal, and sigma 3 is equal to minus 40 megapascal. So already it is arranged, that is sigma 1 is greater than sigma 2 is greater than equal to sigma 3. If you arrange the principal stresses in this order, then the tau max absolute is fixed, that is sigma 1 minus sigma 3 by 2. So we have sigma 1 is equal to 60 minus sigma 3 is equal to minus 40 is divided by 2, and we have SYT value is given as 200 divided by 2 into factor of safety n. So 2 and 2 will cancel out. 60 minus minus 40 is 100. So we have factor of safety will be equal to 200 divided by 100. So we are getting the factor of safety is equal to 2. A machine element is subjected to the following biaxial state of stress: sigma x, sigma y, and tau xy is given. So using sigma x, sigma y, tau xy, we can very well calculate the average stress, tau max, and then we can calculate the value of sigma a and sigma b. Once we find out the sigma a, sigma b, then we'll arrange them in the order of sigma 1 greater than equal to sigma 2 greater than equal to sigma 3. Find out here the factor of safety according to the Tresca theory, and we have given the value of shear strength equal to 100. So according to the maximum shear stress theory, tau max absolute value is sigma 1 minus sigma 3 by 2 is equal to SYS divided by factor of safety. We have given the value of sigma x is equal to 80 megapascal is tensile in nature. Sigma y is also equal to 20 megapascal is tensile in nature. And the shear stress is given as positive value. It means that you have to show the direction of shear stress in such a way that if it is rotated above the center, it will make a clockwise rotation. So this value of tau xy is given as 40 megapascal. So we have sigma average is sigma x plus sigma y by 2. So we have sigma x equal to 80 plus sigma y is equal to 20. That is, we have 100 divided by 2. So in this case, we'll get sigma average equal to 50 megapascal. Maximum shear stress is given as under root of sigma x minus sigma by 2 whole square plus tau xy square. So you have to substitute here the value of sigma x, sigma y, and tau xy. In this case, we have sigma x will be equal to 80, sigma y is equal to 20 divided by 2. That is, we have 60 divided by 2 is 30 square plus tau xy is 40 square. 30 square plus 40 square is 50 square. So we have tau max is equal to 50. So sigma a is the principal stress is given as sigma average plus we have tau max. One value of tau you have to select positive, other is negative. Sigma average is equal to 50 plus 50, that equal to 100 megapascal. Secondly, we have sigma B will be equal to sigma average. This time we'll select the negative value of shear stress. We will get 50 minus 50 equal to 0. Highest value is 100, so we have sigma 1 will be equal to 100. Sigma 2 will be equal to 0. And even the value of sigma 3 will also equal to 0. Check our sequence. Sigma 1 must be greater than sigma 2 must be greater than sigma 3. Absolute value of the shear is given as sigma 1 minus sigma 3 by 2. We have sigma 1 is equal to 100. Sigma 3 is equal to 0 divided by 2. We have yield stress in shear SYS or SSY is equal to 100 divided by factor of safety, that equal to n. So in this case we have factor of safety is equal to 200 by 100, 200 by 100. So we will get a factor of safety is equal to 2. The principal stresses at a critical point of a machine component made of a steel are positive 180 megapascal and negative minus 180. So highest value is 180, lowest value is equal to minus 180. So sigma 1 is equal to plus 180, sigma 3 is equal to minus 180, and sigma 2 will assign equal to 0. So factor of safety using the maximum principal stress is unity, that is given to us. Using this value we can calculate the value of SYT, and then using the value of SYT, the factor of safety using the maximum shear stress theory you have to calculate. For maximum shear stress theory, we have tau max absolute is sigma 1 minus sigma 3 by 2 is equal to SYS divided by factor of safety, or is same as equal to SYT divided by 2 times of factor of safety. And for maximum principal stress theory, we have sigma 1 is supposed to be the maximum principal stress must equal to SYT divided by factor of safety N1. In this case, we have given the value of sigma 1, we'll take the positive value is equal to 180 megapascal, and sigma 2 will assign equal to 0, and sigma 3 we have to take equal to minus 180. So here we have sigma 1 is same as equal to sigma 3, but absolute value is equal to 180. So either you can use sigma 1 or you can use sigma 3 to find the value of SYT, and N1 for maximum principal stress theory equal to 1. So I can use here sigma 1 or sigma 3 both. So in this case I have sigma 1 is equal to SYT divided by factor of safety N1. Sigma 1 is same as equal to 180. SYT we don't know. Factor of safety you have to take equal to 1. So in this case I will get the value of SYT is equal to 180. That will be megapascal. Once I know the value of SYT, I am able to calculate factor of safety for the maximum shear stress theory. So this equation you have to use for maximum shear stress theory. Sigma 1 minus sigma 3 by 2. So we have sigma 1 is same as equal to 180 minus sigma 3 is minus 180 is divided by 2 is equal to SYT, that equal to 180 divided by 2, and factor of safety is N2. 2 and 2 will cancel out. So we get the value of N2 is equal to 180 divided by 180 plus 180 is 360. So in this case we are getting the value of N2 is equal to 0.5, which is less than 1. So it is less than unity, choice A is correct. If the factor of safety is less than 1, in that case the part will fail. So we have a failure. Bar of square and the circular cross section with a length of 0.5 meter length are made of a material with a shear strength equal to 20 megapascal. So we have given here the 4 conditions. In the first case we have given a tensile load of 80 kilonewton and a section is square. Then we have a compressive load of 80 kilonewton and we have a circular rod of 4 cm in diameter, and twisting moment is 64 pi times Newton meter, and bending moment is 320 Newton meter per square section. So we have a square section is 4 cm by 4 cm and circular section of 4 cm. The specimen are loaded as shown in figure. Which specimen will fail due to the applied load as per the maximum shear stress theory? Second choice is torsional load specimen. Third is none of the specimen, and the fourth is a bending load specimen. So we have given here a square section of 4 cm by 4 cm, as well as we have given the circular section of diameter equal to 4 cm, and we have to use the maximum shear stress theory. According to the maximum shear stress theory, we have tau max is equal to sigma 1 minus sigma 3, difference between the largest principal stress and the minimum principal stress, divided by 2. Value of tau max is basically absolute value of shear stress, is equal to SYS divided by factor of safety n, and we have given the shear strength is equal to 20 megapascal. So we have given the value of SYS equal to 20 megapascal. So one by one case you have to solve here. First we'll take the tensile load, and we have given the length of member equal to 0.5 meter. Length as member has nothing to do because the torsion is remain constant, bending moment is remain constant. This will develop the compressive stress and this will develop the tensile stress. So when we have a tensile load, this time tensile load will produce the normal stress, and that normal stress will be equal to sigma is force upon area. We have force is given as 80 kilonewton is 80 into 10 to the power 3 divided by area will be 4 cm by 4 cm is same as equal to 40 mm by 40 mm, and you will get this stress as Newton per mm square, which one is megapascal, and this answer is 50 megapascal. So this is the only stress produced on the tensile load specimen, and therefore we have sigma 1 is equal to sigma is equal to 50 megapascal. Sigma 2 will be equal to 0. Even the value of sigma 3 will be equal to 0. Now actually the concept here is that which will fail. It means that the value of tau max should exceed than SYS. So we'll just find out here the value of tau max, and we'll check that tau max will exceed than SYS or not. So we have tau max absolute value is equal to sigma 1 minus sigma 3 divided by 2. So we are having a value of sigma 1 equal to 50, sigma 3 is equal to 0 divided by 2. So that will be equal to 25 megapascal. Now this value of 25 megapascal is greater than SYS, which is given to us is equal to 20. So if the absolute shear stress will exceed than SYS, then it will fail. So this bar under a load of 80 kilonewton will fail. Now we'll check the second condition. Now since here the load is remained same here, only the direction has been changed. So we have value of stress will be equal to minus 50 megapascal. Cross section area is remained same. So we have minus 50 megapascal. Since this is a negative value, so we'll assign the value of sigma 1 is equal to 0. Sigma 2 is also equal to 0. And we have minimum value is sigma 3 equal to minus 50 megapascal. Again we'll use the condition of tau max, which is given by sigma 1 minus sigma 3 by 2 is 0 minus 50 divided by 2. So this will give you again 25 megapascal, and value of 25 is more than SYS, which is equal to 20, and therefore it will fail. So tensile and the compressive load specimen will fail. Choice A is correct. We have a circular shaft here, and it is subjected to torsional moment, that is the twisting moment T is equal to 64 pi Newton meter. So in this case the failure is due to shear. So we'll calculate here the value of tau xy. We have tau xy is same as equal to 16 times T divided by pi d cube. That is we have 16 into torque, which is equal to 64 into pi. It's a Newton mm. So we have to multiply by 10 to the power 3 divided by pi, and d cube is same as equal to 40 cube. Shear stress will develop equal to 16 megapascal. So in this case we have sigma A is equal to negative of sigma B is equal to same as equal to tau xy, which is equal to 16. So we assign the value of sigma 1 is equal to 16, sigma 2 is equal to 0, and sigma 3 is equal to minus 16. Because we have a pure shear here, and whenever we have pure shear, in that case the Mohr circle will be centered at origin, and we have sigma 1, sigma 2, sigma 3 value equal to 16 and minus 16. So we have tau max, which is equal to sigma 1 minus sigma divided by 2 is equal to 16 minus 16 divided by 2, which is equal to 16 megapascal. And this value is less than SYS, which is equal to 20. So this part is safe. So because of torsion, it will not fail. So this one is wrong choice. In the fourth case, we have again the rectangular section and is subjected to bending moment M. And the value of bending moment is given as 320 Newton meter. And we have a same cross section of 4 cm by 4 cm. So we'll use the flexure formula here, that is value of M divided by I equal to maximum value of the bending stress divided by Y. So bending stress will be equal to maximum bending moment M, that equal to 320. This time we have neutral axis is this axis. So this distance is same as equal to Y, and we have Y is equal to 2 cm. So multiplied by Y is 20 mm divided by I. I is bh cube by 12. Since it's a square, a to the power 4 divided by 12. So it is 40 to the power 4 divided by 12. And is further multiplied by 10 to the power 3 to convert Newton meter into Newton mm. So bending stress is same as equal to sigma x is same as equal to 30 megapascal. So this value will assign to sigma 1, and we have sigma 1 is equal to 30 megapascal. Sigma 2 will be equal to 0 because it's a case of pure bending, and sigma 3 will be equal to 0. So the tau max in this case will be sigma 1 minus sigma 3 divided by 2, which is equal to 30 minus 0 divided by 2. So in this case we are getting the tau max equal to 15 is less than SYS. So this part is safe. So it is not fail due to bending also. It means that it will fail due to tensile and the compressive load, because both time we have the tau max is 25 megapascal and it will exceed the value of SYS, which is given as 20 megapascal. So failure is under the tensile or under the compressive load. The video you are watching is from the app, which is the Mohod class app available on Google Store. And in this app, we'll cover all subjects involved in mechanical engineering for GATE. Join the course directly from your mobile. The link is given here.